Hi there, this is Indranil from EDRMedeso, and in this video we'll have a look into the turbo machinery guided workflow. Now this is a new feature that has been added in the latest release, that is 2022 R1 at this point. Now this turbo workflow, it kind of streamlines our process of setting up a turbo machinery simulation and makes it really easy, fast and efficient to model turbo machinery applications without having to navigate through many options. Now, more information about it is available in 12.1 under the guided workflow tab. So what we'll do in this video is go through the whole process of setting that up, and we'll see just how easy and how user-friendly this is. So the first thing I do is I've opened Fluent without loading any mesh or anything. So I'll just go into turbo workflow and enable it. And immediately it moves away from the outline view and shows me these set of instructions. And by following them, I'll set up my simulation. So the first thing to do is describe a component. Now you have to options from radial and axial compressors or turbines. So we'll do an axial compressor in this case. Right, so now I have 3 rows here. I can always increase or decrease these however I want. Now I am going to be simulating 3 rows. The first one will be a vane, so let's call that IGV because it's inlet guiding vane, and then we have a rotor and a stator. So the type you can select if it's stationary or rotating. All of these are correct in these case. For the number of blades, I'll change these as per my model specifications. For the tip gap, I only have tip gap in the rotor. So I'll select no for all of these and I'll click describe component. Now it asks me to define my blade row scope. So am I going to include these rows in my simulation? So we will do yes for all of these. And now I can import my mesh. So I will quickly import my mesh. Okay, so the mesh is now being read into Fluent, and what Fluent will do now is try to associate all of the cell zones to the respective components, parts of component I described. Right, so let's make the mesh visible. Okay, so there's my compressor. So moving on, next step is associating this mesh. Now Fluent has already done that for me. So as you can see, it's assigned the cell zones from the mesh to what I described. So we'll click associate mesh. And now what we'll do is we'll go on to define all the properties of the mesh. So all the hub and shroud region and the inlet and outlet region for each of those cell zones. Now Fluent, through the means of name selection, has already done that. So as you can see, it has recognized the hub, shroud and the blade region. What we'll still need to make a few changes here. So for example, the outlet in this case, which it hasn't recognized, is an interface between the IGV and the rotor cell zones. So I'll select that. Now symmetry in this case isn't really symmetry, but it's one of the periodic zones. So I'll select I'll remove that from here and I'll select it in here. Okay, now that was for the inlet guiding vane. Now I'll move on to the second zone, which is the rotor. Again, it has recognized the hub, shroud and blade quite easily. So I'll tell it the inlet and the outlet. So that's my inlet. The outlet is that. And again, I'll remove the symmetry because this is the other side of the periodic boundary condition. Right, for the tip clearance in this case, we'll remove it from here because my tip for this particular mesh is non-conformal, so I'll have to remove that from this one. Okay, sorry about that. Select that and then remove the tip from here as well. And I'll put both the tip faces into the blade region. So I'll select those. Right. Okay, now moving down to the last cell zone, I'll need to define a few things here. R1, S1 downstream, again doing the same thing for symmetry. Right, so now I have successfully mapped all my regions, so I'll click map region. Right, now in this part we can actually create our CFD model. So first we'll estimate the number of blades. So once we do that, as you can see, 26, 23 and 30, that's exactly what we specified. So Fluent agrees with our specification of number of blades. Now what we can do is we can model however many passages we want. So if I want, let's say, a 360 configuration of rotor, so I can put in the full number of blades, and that will, as you can see, creates a 360 configuration of that particular cell zone. Similarly, I can change the offset for anything. So if I change the offset of the rotor by, like, say 5 degrees, as you can see, it's moved. So if I do 50 degrees, that moves it a bit more. Right, so we'll leave all of that to the default values and create the CFD model. And now we go on to define the physics. Now you can apply any sort of rotational speed, your operating pressure, and you can choose your working fluid from the options we have. Right, once we do that, it does a few things in the background. As you can see, it's enabling a few of our solvers and enabling a few equations. And now we go on to define the boundary conditions. So we have a few options from pressure inlet, mass flow outlet, and mass flow inlet and pressure outlet. And we can define the pressure inlet conditions and the outlet conditions. And by default, it tries to merge all those cell zones. So we'll click define, and Fluent will apply all of these boundary conditions to the inlet and the outlet zones which we specified in the map region section of our workflow. Okay, so after we've done that, we can just confirm our topology in this case. Now before we do that, if you remember, we did not specify the tip clearance. We just merged it into with the blade. But that is a actual tip clearance. So what we can do is at any point of time we can exit the workflow and go on to our regular solver interface. So I'll hide the workflow, and you can see that's your familiar outline view. So I'll go on boundary conditions and I'll assign the tip faces as mesh interface. So I'll create that as mesh interface, right? So that's done. So if I go back to the workflow now, and I click define turbo topology, but before that, let's go back again and see a few things. As you can see, it recognizes all the boundary conditions, that it has assigned all of those like we wanted to. But let's continue the workflow for now and see what that changes. So if I click define turbo topology, so it seems to be initializing the solution, and it does a few things in the background. Okay, so that's been done. So we'll hide the workflow again and now look at what changes have been made. So starting from above, we can see the energy equation has been turned on. For materials, we have air because we didn't specify any other materials. If we go on to our cell zone conditions, remember we specified as the rotor cell zone to be rotating. So if we go there, okay, so as you can see, the frame motion has been enabled with our rotational velocity that we specified. It has input some kind of expression, but it's the same as the quantity we put in inside the turbo workflow. In the boundary condition, it has specified the pressure inlet that we input. Again, it uses expressions, but it's the same values as what we applied in the workflow. So it has also created the mesh interfaces, as you can see here, and the outlet and the periodic regions are also available. Now we continue with the workflow. And the final two steps are really for post-processing purposes. So as you can see, you can create a few isosurfaces, and by default it creates evenly spaced isosurfaces along the length of the blades. So I'll click Define Turbo Surfaces, and then then it asks me to create report definitions and monitors, and it also asks me if I want result contours in all of those 3 isosurfaces I created. So I'll click Create, and now it's creating all of the report definitions for me, which we'll see in a second. Okay, so I have effectively finished all the steps in the workflow. So now I can hide this workflow. So we went through the boundary conditions and the models and the cell zone conditions, but let's see what it has done for post-processing. So under solution, you can see it has created quite a few report definitions. Now these are your general quantities which you'll be interested into looking when you're performing a turbo machinery simulation. What else? We have a few report files and report plots here. And in the graphics section, it has also created contours on all of these 3 isosurfaces for various quantities. So as you can see, it's very easily helped us set up our turbo machinery simulation without having to navigate through quite a lot of options that's usually available in Fluent. So we save quite a bit of time doing this, and it just makes the whole process quite streamlined. So that was the new turbo workflow feature, and thank you for listening.